3, 2, 1, blast off. Get ready for another fun-filled journey on the NASA Sci Files as the Treehouse Detectives take off for an out-of-this-world vacation. Hi, I'm astronaut Barbara Morgan, and I'm training here at NASA's Johnson Space Center to fly into space. I am also a teacher, and not long ago I was teaching math, science, and technology to 3rd and 4th graders in Idaho. That's why I'm hoping you'll pay close attention as the Treehouse Detectives use all 3 of those subjects to plot their way through the case of the Galactic Vacation.
In the case of the Galactic Vacation, you will be asked the following questions. What are the 5 outer planets? What is a light year? What is parallax? And guess what? When you see this icon, you know you are getting closer to the answer.
Since we're learning so much about Earth science, I have a great activity for you guys. RJ?
What is it? Do we get to go to Mars?
Well, that depends on your imagination. I want you to create an out-of-this-world vacation. Bianca, are you with us?
You mean travel beyond Earth? Like in space?
We'll have to talk more about this tomorrow.
So where do you want to go?
I don't know, but I think I have an idea. Instead of just presenting one travel plan, we can present 3. We can divide up into teams. There are 6 of us.
Sorry, but you'll have to count me out.
What?
I'm taking my own out-of-this-world vacation to Puerto Rico.
Why are you going there?
I'm doing a small internship at Arecibo. You know, the largest radio telescope in the world. But don't worry, you'll be hearing from me.
Maybe she can help us with some research. A perfect place to start. My A encyclopedia. A? Yes, A for astronaut. Now let's see. The first person to set foot on the moon was Neil Armstrong in July of 1969.
I want to be the first person to set foot on Mars.
Mars? That's far away.
Well, to be exact, it's 56 million kilometers when it's closest to Earth.
Let's pull all our destinations on the problem board.
I think Mars might be a cool place to go because I've read that it's a lot like Earth.
Well, I just happen to have my M encyclopedia. And it says here that Mars is a lot smaller than Earth, but has mountains and volcanoes. Interesting.
Everyone agree? We'll put Mars on the problem board under We Know. And we know that Mars will be one of our destinations.
What should be our next travel destination?
The moon. It's closer to Earth than any other object, and if I'm going to travel, I'd like to stay close to home.
Why? Is there some special reason?
I figured out that I can send and receive a stock report to and from the moon in 2.6 seconds. Can you believe that? That's not much of a time delay. Did you know that it only takes 1.3 seconds for a signal to go from the Earth to the moon?
Now really, Tony, do you think NASA astronauts think about the stock market when they decide to go into space?
No, but maybe they should.
Wow, we just got a video postcard from Bianca in Puerto Rico. Check it out.
Hi, guys. I finally made it to the beautiful island of Puerto Rico. I have a history question for you. Did you know that Christopher Columbus claimed this Caribbean island as Puerto Rico for Spain in 1493? Puerto Ricans are now considered U.S. citizens because the United States took over in 1898. These are the streets of Old San Juan, or Viejo San Juan as I learned to say. I love these cobblestone streets and the brightly colored buildings. Look at the magnificent old Spanish architecture. Old San Juan is not very big, but it still has 2 fortresses that protected them during wartime. The huge concrete walls took over 100 years to be built. Puerto Rico has beautiful beaches that make up the shoreline. There are also quite a few churches and humongous mansions, like Casablanca, originally built for Puerto Rico's first governor. You'll never guess who that was. Ponce de Leon. That's right. The explorer who was searching for the Fountain of Youth. Isn't that awesome?
Bianca looks like she's really having a great time.
Yeah, it does. Now, let's see. We have the moon, Mars, and the solar system.
Maybe we should offer our clients a really adventurous trip beyond our solar system. We could go to another star in our own Milky Way galaxy.
Let's put that as our third destination.
Good morning. I'm Ted Toon with Kids Science News Network. Our travel correspondent, I Am Listening, is filing a live report from the Royal Solar System space cruise ship, the Solar Princess. I am...
Ted, this will be the vacation of a lifetime. The ship is magnificent and has everything you could want.
But I don't see any furniture, I am. Where do you sit down?
Oh, Ted, get with the program. We'll be in zero gravity, so there won't be any down to sit. Besides, all of the furniture is stowed in the walls and deploys for use.
Sounds great, I am.
And what's more, you can have water balloon fights without the balloon. In zero G, water makes a natural sphere. Watch.
Way to go, I am. Maybe you should hold off on that water fight until you actually get into space. Well, that's all for now. I'm Ted Toon for KSNN.
Poor I am. I bet the cost of that hotel will be big bucks. Next, I think we need to know the mode of transportation for each place.
Do you mean, how are we going to get there?
Yes, NASA has already landed on the moon, so we know we can use the Saturn V rocket to get there.
I think we're gonna need a really big rocket to go to Mars.
I'm not sure about that. Maybe we need to learn more about our solar system first.
I can't make it, but you might want to go see Dr. D. I'm sure he can help us out.
I'll email him. Let him know that we're on our way. Then I can print off a couple action plans so we can organize our investigation. Go to the NASA Sci Files website to print off your own action plan.
Hi, Dr. D.
Hi, kids. I got your email. You must be working on something exciting.
We are planning a trip to the stars.
Really?
Well, it's just a school project to design a vacation in space, but we want to make it as scientifically correct as possible.
We need to know the distances between our destinations and Earth.
Where are you planning to go on your imaginary journey?
The first place is the moon.
Let's see. The moon is about 400,000 kilometers away. So if there was a road to the moon and you wanted your parents to drive you there, how long would it take?
A couple of days, maybe a week or two.
If you drive at the speed limit, which on the interstates is about 100 kilometers per hour, it would take 4,000 hours or more than 165 days.
That's almost 6 months. And that's without taking any breaks for sleeping, not to mention the lack of gas stations along the way.
So how did the astronauts do it?
Well, it only took them about 3 days because they were traveling at thousands of kilometers per hour. Where else might you want to visit?
We were thinking about Mars.
By car, it would take you 64 years when Mars is at its closest.
That's a long time. I think I'd get bored.
Mars is actually a very good choice.
Why is that?
Well, you wouldn't want to go to the other inner planets. Mercury, the planet closest to the sun, has a rocky, cratered surface that is almost 430 degrees Celsius in the daytime.
Ouch, that's really hot. Doesn't water boil at 100 degrees Celsius?
Yes, and a very hot pizza oven is about 430 degrees. Because Mercury doesn't have an atmosphere to retain heat, at night it can cool to about minus 173 degrees Celsius.
Wow, I'm glad we're not going there.
The next planet out from the sun is Venus. Its surface is covered with lava flows.
Isn't it also completely covered with clouds?
Yes, its mostly carbon dioxide atmosphere is very dense. On the surface, it's hot enough to melt lead.
Isn't Jupiter the next planet after Mars?
It is. Jupiter is over 11 times the diameter of the Earth. It's mostly made of hydrogen and helium. It doesn't even have a solid surface. Saturn, Uranus, and Neptune are also larger than the Earth, and they are similar to Jupiter in that there is no way to walk on their surface.
But Dr. D, you haven't mentioned Pluto. That's my favorite planet.
Pluto is very different than the other planets in the outer solar system. It's small, even smaller than our moon. Some astronomers think we shouldn't call it a planet.
I wouldn't like that.
Well, Pluto is 15,000 times further away from the Earth than our moon, and it's very, very cold. But compared to the nearest star, Pluto is close.
What's the nearest star to Earth?
It's the sun.
Okay, Dr. D, what's the next nearest star?
It's called Proxima Centauri, and it's 4.2 light years away.
What's a light year?
Let me explain. Catherine, how far do you live from your grandparents?
About 2 hours.
You just described the distance with the time it takes to get there. Light travels at 300,000 kilometers per second, so it goes about 10 trillion kilometers in a year. That's what we call a light year.
So if Proxima Centauri is 4.2 light years away, then it would take us 4.2 years to get there if we are traveling at the speed of light.
Yes, but we haven't even come close to traveling at light speed, which is the ultimate speed limit. If you drove your car to Proxima Centauri, it would take over 45 million years. Even our fastest space probe would take over 60,000 years to get there.
Wow, I had no idea space was so big. Thanks, Dr. D.
You're welcome. I have work in my office that I have to do. You can start your research here. I'll see you later.
Bye, Dr.
Bye. I can't do research now. My brain is way too full of information. Let's call Bianca.
Hey guys, I'm at my cousin's school, the Antonio Gonzalez Suarez Bilingual School in Añasco, Puerto Rico. They're doing an experiment in their teacher, Miss Alice Acevedo's science class, learning how to measure distances in space.
Cool. Dr. D just told us about the great distances in space.
Can we take a closer look?
Sure, I'd like Kim and I to tell you all about it. Las puedo decir a mis amigos que ya están haciendo este experimento.
Sí, cómo no. Hola amigos, mi nombre es Kimberly. Oh, perdóname. I'm sorry, I'm Kimberly.
And I'm Ida Cortez. We're here today with our mentors, Brenda Fuentes, Alexis Alicea, Carmen Garcia, and Jadeli Claudio from the Society of Women Engineers. They are assisting us with a parallax experiment to help us understand how astronomers measure distances in space.
Excuse me, we need to listen to my teacher for a minute.
Hoy estaremos realizando nuestra clase de ciencia, un experimento que es utilizado por los astronautas sobre los equivalentes paralelos en el espacio.
Okay, I'm back.
What's parallax?
It's the apparent change in the position of an object. Try this. Hold your thumb out in front of you and close one eye. Then close the other eye.
Looks like my thumb is moving. That's neat.
Even though your thumb really didn't move, it looked like it did, and that's parallax.
So how does the experiment work?
First, we lay out our baseline of rope, 10 meters long. One end is marked A, and the other end is B. Then we place an object not more than 25 meters away from the baseline.
I know this is a protractor, but how is it going to help you measure distance?
You stand on the baseline at points A and make sure that the protractor is parallel with the rope.
Why'd you put the pencil on the vertex?
Putting it there helps you line the object up as you look at it.
What comes next?
Now move another pencil around the outer edge of the protractor until it lines up with the object.
How do you read the protractor?
Your partner will actually read it for you and record the angle.
Next, we move to the other end and repeat the steps. Notice how the flagpole seems to have changed its position and appears as a different angle.
Now what do you do with your data?
Plot it on graph paper. Draw a 10 centimeter baseline at the bottom of the paper and then draw in our angles.
Do the two lines intersecting mean anything?
Yes, it is telling us the distance that the object is from the baseline.
How do you determine the distance?
Draw a perpendicular line from the point of intersection to the baseline and then measure it.
What's the scale?
We use the scale that means 1 centimeter on the graph paper equals 1 meter outside.
I get it. So if the line measures 15 centimeters, the distance from the object is 15 meters.
Astronomers are able to see an apparent shift in the nearby stars as the Earth revolves around the sun.
That's really interesting.
And thanks to the Society of Women Engineers for providing us with mentors.
Visit the NASA Sci Files website to learn how to get your own classroom mentors. Thanks, Kim and Ida. I've got to go to my next meeting. ¿Qué hora es?
It's 3 p.m.
I'd better run. Adios, amigas.
Adios.
With planets and stars so far apart, it sure is good to have a way to measure the distance.
It looks like you're gonna have to travel a long ways in space just to get to Mars. We better talk to someone about what it's like to live in space.
Email NASA Johnson Space Center and see if there's any possible way that we can talk to the International Space Station crew.
Yeah, right. Good luck.
You never know. NASA does want to inspire the next generation of young explorers, and we are the Treehouse Detectives.
That's right.
So, what's up? Which destination is ideal for an out-of-this-world vacation? Will distance be a deciding factor? What else should the Treehouse Detectives consider before choosing a destination? In this episode of the Galactic Vacation, be prepared to answer these following questions. How does gravity most affect the ISS crew? How are the phases of the moon created? And what causes the seasons on Mars?
Wow, I never thought it really happened. Hope they got my message to get here quickly.
Hi, Jacob.
Hey guys, you will never guess who we are going to talk to today.
Is Bianca calling today?
No, better than that.
Better not let Bianca hear you say that.
I think even she would agree with me.
Okay, so who is it?
The crew on board the International Space Station.
No way.
Yes, I came through again.
He's going to be hard to live with.
The email said we were to dial them up at... We need to call now.
Hi, Treehouse Detectives. Greetings from International Space Station. I'm Ken Bowersox. On my left is Don Pettit. To my right, Nikolai Budarin.
Hello. Greetings from the treehouse, sir. I mean, sirs. No one's gonna believe we're talking to you. I hope I remember to tape this. Can you tell me how living in space is different from living on Earth?
Living on Space Station, we are weightless. And so all the effects that you see of gravity on Earth, you don't see here on Space Station. So things will float off. You have to keep all your little tiny parts corralled. You set something down on a surface, it'll float away.
Commander, can you tell me if you've been sleeping any differently?
No, not really. Here in orbit, I sleep pretty much the same as I do down on Earth. I dream and I sleep very comfortably and almost the same amount every night.
How do you use the bathroom?
The bathroom here on Space Station is not that much different than what you'd find on the ground, except we use fans and moving air to replace many of the functions that gravity provides.
Thank you very much. That was awesome.
I think we're ready to start planning our trip to the moon. Email the others and let them know that I'm going to talk to Dr. Pryor with NASA Langley Research Center.
Okay. I'll also print off a Get Up and Go sheet from the NASA Sci Files website for you to take with you.
Would you like to be an astronaut?
Yeah, maybe.
Say, aren't you one of the Treehouse Detectives?
Sure am. And you must be Mr. Pryor from NASA Langley.
Yes, I am. And I understand from your email that you want to know more about the moon.
Yes, I was looking at the moon the other night, and I was wondering why it had different shapes.
The different shapes are called the phases of the moon. Step over here and I'll show you what I mean.
What do you do with the lamp?
The lamp represents the sun. Think of this ball as the moon, and you're the Earth.
Okay.
Now hold the ball in front of you and towards the sun. What do you see there?
The side that I'm looking at is dark.
That's right. That's called the new moon phase. Now turn to the left a quarter turn and keep holding the moon in front of you and tell me what you see.
Now, half the side that I'm facing is lit.
That's called first quarter. Keep going.
Okay, now the whole thing is lit. This must be a full moon.
Keep going.
Now only half is lit, but it's the other side.
Yes, that's called the moon's third quarter phase.
Okay, I get it. So the phases of the moon are created when the moon revolves around the Earth.
The same side of the moon is always facing the Earth, and as it revolves around the Earth, different portions of the surface are illuminated by the sun. Those are the lunar phases.
Why do we only see one side of the moon?
The moon rotates on its axis once every 27.3 days. Turns out it's also 27.3 days that it takes to revolve around the Earth. That's why the same side of the moon is always facing the Earth.
How old is the moon?
The moon is a lot older than you and me. It's about 4.5 billion years. It's roughly the age of the Earth, but that's where the similarities end.
What do you mean?
Well, there's no atmosphere on the moon, and the gravity's much less. It's only about 1/6 the gravity of the Earth at the surface of the moon.
So if I weigh 90 pounds on the Earth, then I would weigh 15 pounds on the moon. Cool.
That's right, and the surface of the moon is very different, too.
So what are those big circles that I see when I look at the moon?
Those circles are craters from the meteors and the asteroids that have impacted on the moon over the years. There's no water or weather erosion to help get rid of them, so they're all still there.
So what's the surface like?
The surface is generally gray in color and sandy. It feels very much like this concoction.
It feels like dust.
You're right. There was a real concern early in the moon program that it might be like quicksand and the astronauts could sink in it. But of course, that did not happen.
Good thing they didn't. Does the moon affect the Earth at all?
Oh, yes. The moon affects the tides. And if we were on the beach... How did that happen? I don't even want to ask. The moon's gravitational pull depends on the distance. It's greater on the oceans closest to the moon than on the center of the Earth. This tends to pull the oceans into a big bulge.
Anything else?
Actually, the moon is increasing the length of our day by 0.0016 seconds every century.
We can measure that? Wow, I'm impressed. How does it lengthen the day?
The Earth's tides act like a brake to gradually reduce the speed of the Earth's rotation.
That's so interesting. Thanks, Mr. Pryor. You've given me a lot of useful information.
Now I wonder how we're going to get back to the museum.
We're learning all about the moon and Mars.
The moon is a really cool place. There's a lot less gravity there.
And that's gonna make things so much easier to do.
You think so? You might be surprised how difficult living in an alien environment can be.
How is that?
There are a lot of things you might not think of. Have you ever gone camping in the mountains?
That's an alien environment?
Well, not quite the same thing, but you do have to think a little differently. For example, on a 10,000-foot mountain, the air pressure is low and water boils at 90 degrees Celsius instead of 100 degrees. So food doesn't cook as quickly.
Oh, I get it. So on the moon, where there isn't any atmosphere, the water would boil at an even lower temperature.
Wait a minute. If there isn't any atmosphere, then we would have to bring our own oxygen supply.
Actually, you couldn't just bring an oxygen mask. You would have to have a spacesuit. I have one in my closet.
Why would you need that?
A spacesuit protects you from temperature extremes. On the moon, it's about 130 degrees Celsius in the daytime and minus 170 Celsius at night. More importantly, because there's no air on the moon, your blood would boil without a spacesuit. Oh, I say you found it.
Okay, you sold me on the spacesuit. Is there anything else?
Well, now you'll find that tasks are tougher with the spacesuit. I'll give you a few simple things to do.
Even easy tasks become difficult.
Let's try something else and suppose you're on a planet where the gravitational force is very strong. For example, if you could stand on Jupiter, you'd weigh 2.5 times your Earth weight. Now I'll cut you some slack and just make you weigh 1.5 times your normal weight. 30 pounds. And 4 more here. And here.
Thanks a lot. Now it's really hard to move.
Imagine living on a world like the moon where it is dark for 2 weeks at a time and then light for 2 weeks.
It'll be pretty hard getting used to going to sleep when it's light for that long of a time.
That'd be a lot easier to live with than wearing these weights.
So what have you learned about Mars?
Well, I haven't done a lot of research on Mars yet.
Why don't you go see Dr. Bobby Braun with NASA Langley Research Center? He's done a lot of research on Mars.
Thanks, Dr. D. That's where I'm headed next.
See you later, guys.
Oh, hi, Dr. Braun.
Hi, RJ. I hear you want to learn about Mars.
Yes, we're trying to plan the ultimate future travel trip. One of the places that we wanted to stop on our cruise was Mars.
Mars is an excellent choice because of all the planets in the solar system, Mars is the most like the Earth.
How is it like Earth?
Well, just like Earth, Mars has a solid surface with mountains, valleys, volcanoes, and even craters. Mars even has the largest known volcano and canyon in the solar system.
Wow, those will make great tourist attractions for our travelers. Isn't Mars smaller than Earth?
Yes, it's about half the diameter of the Earth, but it has the same land area since Earth is covered largely by oceans.
Is there water on Mars?
There's evidence that a vast amount of liquid water flowed across Mars's surface in the past, but there's no liquid water on the surface today. However, there is frozen water beneath the surface.
Does Mars have seasons just like we do here on Earth?
Yes, just like the Earth, Mars is tilted on its axis. It's this tilt that causes the different seasons. Astronomers have even noticed that the polar ice caps shrink in the Martian summers and get larger during the Martian winters.
What's the atmosphere like on Mars?
Now that's very different from Earth's. Mars' atmosphere is very thin and has only about 1/200th of the amount of gas that we have on the Earth. And it's mostly carbon dioxide.
Yes, and the Earth's atmosphere is 21% oxygen, 78% nitrogen, and 1% trace gases. So I guess we have to bring oxygen for our travelers.
Yes, or you could make oxygen from the water buried beneath the surface of Mars.
That's right. Water is H2O, 2 part hydrogen and 1 part oxygen.
Right. And because Mars is 1.5 times farther from the sun than the Earth, you better make sure that you're outfitted to withstand the cold temperatures.
I'm wondering if that's going to be a problem, because I read that the spacesuits and the backpacks that the Apollo astronauts wore were almost 200 pounds.
Fortunately, the gravity on Mars is less than that of the Earth.
We learned from Mr. Pryor that the moon's gravity is 1/6 in that of the Earth. Is Mars less than that?
No, actually, Mars's gravity is about 1/3 that of the Earth.
To compare in like denominators, first you have to find a common denominator. For example, with the fractions 1/6 and 1/3, the common denominator is 6. Then you multiply 1/3 by 2/2, which is actually 1. Then you get 2/6. Then it's easy to see that 2/6 is greater than 1/6.
That's right. I have an idea. Let's go see how much you would weigh on Earth and on Mars. It looks like you weigh 100 pounds here on the Earth, and the spacesuit's 200 pounds. So what would that be on Mars?
I know you wouldn't weigh 300 pounds, because then you couldn't walk around.
Well, that's right. It would be 1/3 at 300 pounds.
That's 100 pounds. That's the same as I weigh on Earth. Oh, that's too bad. I was hoping that if I weighed less, I could jump higher. Then I'd be a great basketball player.
Right, but if you had an indoor basketball court and didn't need the spacesuit, you'd weigh a lot less.
I can see it now. Basketball camp on Mars. We're guaranteed a slam dunk.
There you are. I've been waiting for you guys to get here.
What's the hurry?
Bianca's ready to give us another video postcard.
Que pasa? In other words, what's up? I'm back again, this time in Loiza, Puerto Rico. And part of the Puerto Rican tradition is the dancing. Take a look. This is Carnival Rumba. Check them out. They're called the Happy Dancers. They told me the reason they're called this is because when you dance, you're happy. Don't you love their colorful costumes? But they weren't the only ones performing tonight. Taino Indians, Africans, and also Spaniards brought their dance to Puerto Rico. Meet my new friends and watch closely as they use their fancy footwork to proudly express their heritage and their history. I guess it's time to bamba.
All right, I'm ready to go. I think we have enough information to plan our out-of-this-world vacation.
I think we need to go to the problem board. What do we know?
We know that living in space is a lot harder than living here on Earth, and that it will definitely change our sleeping and eating habits.
We know that gravity is different on the moon and on Mars.
We've learned how to measure distances in space.
We learned how far away our destinations are.
We need to know more about space travel. How are we going to get there?
Dr. D talked to us about how long it would take to travel to the moon and Mars. Maybe we need to ask more about space travel. Let's call him up.
So, what's up? What are the advantages of going to the moon instead of Mars? Why would Mars make a good choice for a vacation? How will the Treehouse Detectives travel to their destination? Are you ready to answer these questions? What is acceleration? Why do you need to exercise in space? What is plasma?
Do you see Dr. D yet?
I wonder why he asked us to meet him here at Busch Gardens, Williamsburg.
Oh, there he is.
Hi, kids. Welcome to your astronaut training program.
Astronaut training? I thought we were here to ride roller coasters.
That's exactly right. I want you to be able to experience the thrill of space travel. And the best way to do it here on Earth is on a roller coaster.
What do roller coasters have to do with space travel?
I know that roller coasters go fast, but not nearly as fast as rocket ships.
That's right. But it turns out the thrill of space travel doesn't come from going at high speeds. It comes from accelerations.
We've learned before that acceleration is a change in speed or direction.
Precisely. The important point is that forces are needed to cause accelerations. Remember the law of inertia?
I remember. It states that objects at rest stay at rest, and objects in motion remain in motion.
Very good. Let's get this bowling ball rolling. What if I hit it from the side?
I would guess that it wouldn't change speed. I'm not sure what it would do.
Let's try it.
It changed direction without changing speed.
The same thing happens to the roller coaster car at the bottom of the hill. It has inertia and wants to maintain its downward motion, but the track pushes the car perpendicular to its motion and sends it uphill.
What does the push of the track do to the passengers?
It makes them feel heavy. The faster the coaster is going, or the tighter the turn, the heavier they will feel.
How heavy will you feel on a roller coaster?
Here on the Alpengeist, you feel about 4 times heavier than normal at the bottom of a couple of the hills. It turns out the space shuttle astronauts only feel 3 times heavier than normal when the shuttle is taking off.
So you were right. We are going to be in training to be astronauts.
The difference is, on the Alpengeist, you feel heavy for only a few seconds at a time. But on the space shuttle, you feel heavy for about 8 minutes.
Don't astronauts also feel weightless? Will we be able to experience that on the Alpengeist?
You bet. Once the engines are cut off after about 8 minutes and the shuttle goes into orbit, the astronauts are weightless. Weightlessness is experienced when only gravity acts on an object. It's called free fall. Let me show you. When I jump off this bench, the points of my hat will float as if they're weightless, and this spring hanging from my hand will collapse.
Wow, Dr. D, what you go through to show us how science works.
So where in the coaster ride are we going to be falling?
Free fall is not always down. Remember, it's when only gravity acts. So when I throw this koosh ball, watch which path it follows.
I've seen that before with the Vomit Comet when we were learning about habitats. I think it's called a parabola.
Very good. The coaster goes over a parabolic hill and twists at the same time. For a few seconds, you're weightless.
This is going to be exciting.
Can we go on the ride now?
One more thing. You can tell how heavy you feel by watching this accelerometer. When you feel 3 times as heavy as normal, this mass will be pulled onto this point right here. Einstein told us that being heavy on a roller coaster and being heavy on a big planet are the same thing.
So I guess we're preparing for both space travel and visiting an alien planet.
Let's go on the ride. I'm ready to be an astronaut.
Okay, it's good to experience the physics and not just talk about it. Don't forget to watch the accelerometer and try to figure out where you are when you feel the heaviest. Come on, let's go. Ready? Let's go. Here we go.
That was so great. I felt heavy at the bottom of the hills. I noticed the accelerometer read more than 3 a number of times, but I lost count.
I noticed I felt weightless a few times.
I had no idea where I was on the ride, but it was exciting.
Thanks, Dr. D. Now we have some practical space travel experience.
You're welcome. You'll be great astronauts. Oh, I've got to run. See you later.
Bye, Dr. D.
Bye.
Thanks. That was so much fun. Wish it was that easy to go into space.
Okay, let's organize what we've learned.
Let me get the laptop, and then we can fill out the problem board. Go to the NASA Sci Files website where you'll find lots of tools to help you in your own investigation.
We learned that acceleration occurs when you change speed or direction.
We also learned that sometimes you feel lighter or heavier on a roller coaster, depending on the situation.
So where do we go next?
We just learned that it's not as easy as we thought to go into space. Why don't we learn more about space travel?
I think we should learn more about future space travel.
Why don't you do a search?
I'll go to the NASA homepage, www.nasa.gov. I'll put in future space travel.
Wow, NASA's Marshall Space Flight Center has an exhibit called Starship 2040.
Here's a list of where they'll be exhibiting.
Look, there's an exhibit in New York next weekend. My mom and I are going up. Maybe we can go and talk to them. Hello, Mr. Wang? Hi, I'm Catherine. My friends and I are designing a travel brochure for a trip into space. But we need to learn more about future space travel.
Well, Catherine, you've come to the right place. Welcome to Starship 2040.
Thanks. Do you really think there will be tourists in space?
Yes, and probably in your lifetime. Every day, scientists, engineers, and highly trained people are working to make space travel a reality. In the next 40 years, we're looking at vacationing, working, and even living in space.
Wow, that would be awesome. So how do you travel in space?
With systems like this. This is a navigation and vehicle health monitoring system. Crew will need to access information like this throughout the ship.
That makes sense. This isn't what I think it is it?
Yes, it is, but it is modified. It's more than likely that your ship won't have any gravity. So therefore, the bathrooms will have to be changed so you can wash your hands, brush your teeth, or even take a shower.
Is this the toilet?
Yes, and you must remember the phrase, always buckle up. This is really important in using the bathroom in space, because if you don't, a really big mess can happen.
We don't want that. Using the bathroom will be kind of weird.
Yes, and of course, after you finish using the restroom, you need to wash your hands, so you can use this washing facility.
Why are there chairs on the ceiling?
That's simple. When traveling in low gravity, every floor can be a ceiling and every wall can be a floor. You float from deck to deck.
I would have a great time floating around, but what else can you do for fun?
Well, you have your own personal entertainment center. You can watch movies, play games, or even surf the space net. Or one day you can even talk to your friends face to face.
That sounds like my kind of travel. We learned in the case of the biological biosphere how important it is to exercise. Do you have any exercise equipment for space travel?
We sure do. Without gravity, the human body gets lazy. Today's fittest astronauts even have to exercise at least 2 hours to stay in shape. We have a stair stepper, a climbing wall, and a treadmill that you can stay in shape with while you're in space.
How do you eat while traveling in space?
Well, the Starship has a self-serving kitchen. You pre-select your meals before you go on your trip, and once you're hungry, you dial them up, and they're prepared just the way you like them.
Wow, this trip will be so cool. I can't wait to the year 2040. Thanks, Mr. Wang, for all your help.
You're welcome. Send me a copy of your travel brochure when you're done. We might just want to use it one day.
What are you doing, Jacob?
I was just investigating a propulsion system for our space travel out of the galaxy.
With the balloon and a string?
I was just starting with the basics, investigating the problem.
I just got an email from Catherine in New York. She says we should talk to Dr. Franklin Chan Diaz. He's an astronaut.
I Am Listening is on her space cruise and files this live report from space. I Am?
Ted, we've begun our 3-hour tour to Neptune. Soon we'll be swimming and windsurfing on a whole new planet.
I Am? The surface of Neptune is about minus 200 degrees Celsius and is made of frozen methane and ammonia. If you go swimming, you won't be going very fast. But if you go windsurfing, you'll be going very fast. Winds on Neptune have been clocked at 2,000 miles per hour.
What? That's not what the brochure says.
And unless you have a plasma drive, it takes about 15 years to get there.
15 years? Well, it's a good thing they have an all-you-can-eat buffet. I'm headed for lunch, Ted.
Speaking of plasma drives, NASA astronaut Franklin Chang Diaz is working on just such a propulsion system. Plasma drives will replace today's chemical fuel rockets and make space travel faster than ever.
He sounds like a man we need to talk to. Surely he can help me out with my test propulsion system.
Let's try and dial him up.
Hi, I understand you'd like to know more about propulsion systems.
Yes, we're trying to design an out-of-this-world vacation and realize because of the great distances in space, we might need to get there a different way.
How do we currently travel to space?
We use chemical rockets that produce a jet of exhaust gases, and these gases propel the ship forward.
How long would it take a spaceship to reach Mars?
About 10 months.
10 months is not that long. Why aren't chemical rockets good enough?
To an astronaut, 10 months in space is a long time. Persistent radiation of space will weaken your immune system and also damage your bones. So you would like to go there as fast as you can.
Yes, we learned a little about physiological losses from Beth Shepard in our last case.
What will the propulsion systems in the future be like?
Instead of using the heat from a chemical reaction, the future rockets will use something called a plasma.
What's plasma?
Plasma is a gas which has been superheated to millions of degrees. It is even hotter than the interior of our sun.
That's hot. How will the rocket not burn up with such a high temperature?
Since there is no known material that can take those temperatures, we will not use materials. We are going to use an invisible force field that will hold this plasma and prevent it from touching any surrounding material.
How will it work?
The magnetic field is like an invisible tube that will contain and guide the plasma to provide a much hotter exhaust.
Where will you get the energy to heat the plasma?
We will get the energy from electricity generated by an onboard nuclear power plant.
Will plasma rockets be used to travel outside of our solar system?
Eventually, plasma rockets will become even more powerful, where the energy of the plasma will be generated by an internal source, a thermonuclear reaction called fusion.
I've heard of fusion. It sounds fast.
Fusion rockets will be so fast that it will be possible for people to travel to the farthest reaches of the solar system and be able to return to their families within a couple of years.
How long before we have this type of space travel?
It is hard to tell. One never knows about progress. It could be as long as 50 years, but then again, it could be less.
Why so long?
Developing new technology takes time, and we do want to make sure it's safe.
I know NASA is very cautious and always puts safety first. Thanks, Dr. Chang Diaz, for giving us a lot to look forward to in the future.
You're welcome. And don't forget to have fun designing your vacation. And be sure to call if you need anything else.
Wow, that was cool.
I think we need to go to the problem board and organize our information.
What do we know?
From Catherine's notes, we've learned that space travel will be a lot different from today's travel.
And we know from Dr. Chang Diaz that it's going to take a propulsion system unlike any we currently have to go beyond our galaxy.
I think we need to know more about our galaxy. Wait, guys, here's Bianca from Puerto Rico.
Hi, guys. I'm up here on top of the Yokohu Tower, 1,575 feet in the air, overlooking the National Caribbean Rainforest, or El Yunque. This is the only rainforest in the U.S. National Forest System. According to the ancient Taino Indian legend, the good spirit Yukiyu protects Puerto Rico and its people from his mighty mountaintop throne. Can you believe that more than 100 billion gallons of rain falls here every year? That's why there are so many rushing streams, rivers, and there's even waterfalls like this one. There are these beautiful and patient flowers and all of these vines everywhere, and they even have over 240 different species of trees. I finally made it to the Diego waterfall. Isn't it great? But I think it's time for me to take a swim. By the way, my next stop is my Arecibo internship.
Bianca is so lucky. She's actually visiting the largest radio telescope in the world. Maybe she can do some research for us.
I've heard that Arecibo looks for extraterrestrial life.
Do you mean aliens?
I've heard that they use radio telescopes to listen for them.
I think we should ask Bianca to research the Out of the Galaxy stop on space travel.
Great. Email her and let her know. What's up? Will space travel become common in your lifetime? Are plasma rockets the answer to future space travel? Which destination will the Treehouse Detectives choose? In the last episode of Galactic Vacation, try to answer the following questions. What is a radio telescope? How do we look for life in the universe?
Well, hi, Bianca.
Hi, Dr. D. Welcome to Puerto Rico. Thanks for inviting me to come look through your telescope.
Glad to have you.
How does it work?
This is the reflecting telescope. It has an 8-inch mirror that gathers a lot of light and makes dim objects visible.
That's cool. So we can see the planets and stars.
Yes. Did you know that at the Arecibo Radio Telescope in 1992, the very first planets outside of our own solar system were discovered? Since then, we've discovered over 100 of what we call extrasolar planets.
You mean there are other planets not in our solar system? Why didn't we find them sooner?
Planets are much smaller than stars, and because they don't produce their own light, and they're light years away, they're very dim and difficult to detect.
Do you think any of the planets have life?
We don't know yet, but a lot depends on what kind of star they orbit.
Stars all look the same to me, except some are brighter than others.
Take a look. I've got the star Betelgeuse in the telescope.
Betelgeuse. Isn't that a movie?
Betelgeuse is a giant star. It's dying, and in its old age, it expanded to more than 500 times the size of the Sun, which is larger than the orbit of Mars.
I guess that if there were life on any planets around Betelgeuse, it wouldn't have survived.
That's right. We don't expect to find life around giant stars. Do you know that stars come in different colors?
Stars have colors? I guess Betelgeuse did look a little red.
Here, check out this star called Rigel.
It looks blue. Does the color mean anything?
Yes, the color indicates temperature. Blue stars are hot and red stars are cooler.
That's different. Usually blue is cold and red is hot. Isn't our sun yellow?
Yes. Our sun, a dwarf star, is not too hot, it's not too cold, it's just right.
Very funny, Dr. D.
In order to have life as we know it, a planet must be just the right distance from a star so liquid water can exist. It's called the habitable zone. If the star is too hot, there'll be too much ultraviolet radiation.
I know about that. It's what causes you to get sunburn. Luckily, I know about UV rays, and I'm wearing lots of sunscreen while here in Puerto Rico.
Yes, and hotter stars don't live very long, so there might not be time enough for conditions necessary for life to develop.
So does that mean there will only be life on planets that have stars exactly like ours?
They don't have to be exactly the same as ours, just similar. They can be a little hotter or a little colder. Here, take a look at this.
It looks like a blue cloud.
It's called the Orion Nebula. It's a glowing cloud of hydrogen gas 1,500 light years from Earth. Right now, stars are forming just behind this glowing cloud.
If a star were born right now, we wouldn't know about it for 1,500 years.
You've been paying attention. Let me show you something really spectacular.
It just looks like a fuzzy patch of light.
It's called the Whirlpool Galaxy. It doesn't look very bright because it is so far away.
How far away is it?
We don't have an exact distance, but we estimate it to be between 15 and 37 million light years. It has about 100 billion stars in it.
That's amazing. With 100 billion stars, there's got to be a lot of just right stars, and at least one must have a planet with life on it.
Well, if there isn't, there are hundreds of billions of other galaxies that might have life.
Wow, trillions of galaxies with billions of stars. My mind hurts. Thanks, Dr. G.
Anytime.
See you later.
Bye.
Mi nombre es Bianca Baker, reporting here for my internship.
You can proceed.
I'm at the Arecibo Observatory. Let me tell you a little bit about its history. The observatory began operating in 1963. It has a 20-acre radar dish and a 1,000-ton platform suspended above it. I'm going on a tour later. Do you want to come along?
Hi, Bianca. Welcome to Arecibo. I'm Dr. Jose Alonso.
Nice to meet you. This place is so huge. I can't wait to see everything. Where do we start?
I have a perfect spot where you can have a great look at the telescope.
Wow, this is amazing. I can't believe I'm 550 feet above the dish. But I have a question. Is a regular telescope like a radio telescope?
The difference is that regular telescope gather light and radio telescope gather radio waves.
Where do the signals come from?
Most objects in the universe, like galaxies, pulsars, quasars, they emit radio waves.
How does the radio telescope work?
Radio signals, which are coming from the sky, they will be reflected from the very large reflector underneath. Then they will come up and be gathered into special receivers that will transform them into an electrical signal. That signal will then be sent to the control room where scientists will be able to see them.
Why electrical signals?
So that the signals can be monitored by these special computers. Here's an example on how the signal might be displayed.
It looks like a graph.
Bianca, I want you to meet Tapasi Ghosh. She's one of our astronomers.
Hi, Bianca. Hello. Puerto Rico is an island in the Caribbean, so why would they choose to build a large telescope here?
I have some work to do. I see you later, Bianca.
Bye.
Do you know we can fit 16 football fields in this area?
16 football fields?
They had to find a huge sinkhole to put it in. Also, do you think you can move a 1,000-foot telescope around?
I wouldn't even want to try.
We knew we couldn't move such a large telescope, so it had to be put in a place where it points in the right direction.
Where does it need to point?
It points upwards, but one of the main purposes of this telescope is to observe planets, and from near the equator, you can observe them across the sky for a long time.
I understand now, but where are we going next?
I'm going to take you under the dish, and then we come back to the control room.
I can't believe they were underneath the telescope, but I can see the sky through it. Why are there holes in the dish? Don't the holes let the radio waves leak through?
No, it's like bouncing a ball off a tennis racket. If the ball were smaller, then it will go through the hole. Likewise, radio signal, being of longer wavelength, bounces off the dish, but optical signal won't.
That's right. We learned about the wavelength of light in the case of the mysterious red light.
Bianca, let me take you to the control room now. You will meet our director, and he's going to tell you about alien research.
Hi, Bianca.
I'm Dr. Altschuler. I'm the director of the Arecibo Observatory. Are you enjoying your tour?
Yes, this place is awesome.
Yes, it's an exciting place to work. We study things very near, like our atmosphere. We study things in the solar system, like the moons of Jupiter or asteroids. And we even search for extraterrestrial intelligence.
Have you found any yet?
No, not yet, but we're not discouraged. It's a very big place to look for something like this, and we have to keep on searching.
Why do you look for life in the universe?
Ever since the beginning of mankind, we've always wondered, by looking at the stars at night, if we're really alone. And we would like to really know. This would be the greatest discovery ever.
How do you look for life?
Well, one way is to search for artificial signals.
What's that?
A signal that is not produced by nature. So if we detect a signal like that coming from somewhere else, we will probably conclude that there's somebody who made that signal.
How do you locate these signals?
Well, researchers bring special equipment to connect to our huge telescope, and then we point the telescope to thousands of stars that look like and are like the sun.
Dr. D told us that sun-like stars are the most likely to have planets with life.
He's right. And the ones we know have planets will be looked at very carefully.
Have you ever tried to send an alien a signal?
We did that once in 1974. We sent a signal that had something to say about who we are and how we are and where we are. But usually we listen.
Do you really believe there's life out there?
It's such a large universe, so many stars, many with planets. It would be difficult to think that we're just all alone in this big place.
What would you do if you were contacted by other intelligent life?
It would be the greatest discovery ever. But before we go out and announce it to the world, we would have to confirm and make sure that it is real, that we didn't make a mistake, and probably ask other observatories to look also and see that it is true.
I'm not sure I would even know what to say if I made contact with an extraterrestrial being. Would you?
If we ever make contact here with an extraterrestrial intelligence, Bianca, we'll call you.
Thank you. Hi, guys. I'm back.
Well, hi, Bianca. Great, now that you're back from your out-of-this-world internship, we can get to work on the travel brochure.
What did we decide to do? For some great ideas on how to present the final report on your investigations, visit the NASA Sci Files website.
I think we should create a space cruise line.
That's a great idea. The moon could be our first dock of call, Mars our second, and somewhere in the galaxy our third. I had the cruise ship.
Our brochure can read something like this. You can begin your out-of-this-world vacation with a 3-day trip to the moon.
Unfortunately, the accommodations in Foon aren't exactly 5-star.
Yes, as we learned from the ISS crew, eating and sleeping are much different from on Earth. But Starship 2040 says things will be much better in the future.
At least we can advertise, truthfully, that on this cruise, you'll be at your thinnest.
Huh?
Remember, because of less gravity on the moon, one will weigh 15 pounds instead of 90.
And our travelers won't need to worry about buying expensive cruise clothing.
Because of extreme temperatures and lack of air, spacesuits are required.
From the moon, we could head to Mars.
Remember, Mars is 1.5 times farther from the sun than the Earth, so it's a lot colder.
It also has some great tourist attractions, such as the largest volcano and mountain in the solar system. Make sure you sign up for that tour, Jacob.
Yeah, right. Finally, our last stop will be the next nearest star in our Milky Way galaxy, Proxima Centauri.
I hope our group has a lot of time, because even in our fastest space probe, it could take 60,000 years to get there.
Unless we get a new propulsion system, I don't think we'll be making our last stop.
If we do, then who knows? The researchers from Arecibo might pick us up on their radio telescope.
We might even run into extraterrestrial life.
This is going to be a great brochure.
We should also take some video so we can make a commercial too.
Great idea. Come with me. So what do you think, Tony?
Jacob, I think you're gearing up for the wrong kind of cruise.
No, just getting in the mood for our out-of-this-world vacation.
I'm glad to give you this key and the logo of Loíza as a present in the name of Loíza Municipality.
Muchas gracias.
De nada.
The difference is, on the Alpengeist, you have to let you...
galaxies and billions of stars.
All in this universe of ours.
NASA Science Files was made possible through the generous support of Busch Gardens Williamsburg, SeaWorld, and NASA Langley Research Center's Aerospace Vehicles Technology Office. Captioning provided by NEC Foundation of America.